Today we're going to be talking about finding limits by picture and by table. And what you need to realize is, what is a limit? A limit is a value a function approaches but never equals. Okay, so we have the limit as x goes to 3 of our function equals 8 or is 8. Now, there's a good analogy here of a speed limit sign. A speed limit sign. You want to approach the speed of 7.5. But the very second that you hit that 7.5, the police can give you a ticket. Okay, so you want to keep that in mind. It's a limit that it approaches but never equals. So we get infinitely close to our value. Okay, in existence of a limit, there is a key definition that you need to realize. The left-sided limit has to exist. So the limit is you're approaching some function from numbers a little bit less. And how you can tell it's numbers a little bit less is that little negative sign kind of in the exponent. And also your right side exists. So you're approaching your function from numbers a little bit more. Also is going to exist. And then those two limits are going to equal each other. So again, make sure you write down this definition and that you know this definition. Okay, limits of a continuous function. I'm just going to go through some different examples of when limits do and do not exist. Okay, so the limit as x approaches 2 from numbers a little bit less. So my x value right here is 2. As I approach from numbers a little bit less, our value is 3. Now our limit as x approaches 2 from numbers a little bit more of our function. So from numbers a little bit more, we go towards 2. That value is also 3. So since those values are the same thing, we can say our limit equals 3. So a limit of a continuous function ends up being that function value. That's not always going to be the case. We could, for example, could have a hole in the function. So we have a linear function. Now our limit as I go to 3 from numbers a little bit less of our function. So from numbers a little bit less, the approaching from the left side. What y value am I going to? I'm going to -6. And now our limit as x approaches 3 from numbers a little bit more of our function. So numbers a little bit more, but going towards our value. I get infinitely close to it. Remember, I'm getting infinitely close, but never equaling. So that's why I can get infinitely close to this open hole. I just have an open hole at 3. So our function value does work out, or the function value does exist, but our limit ends up equaling 6. Now I jump discontinuity. So as I approach numbers from the left or less and numbers from the right, I approach the same value of +6. But now notice our function value is all the way down here at -2. Notice the differences between those two things. Now one-sided limits, and I've already kind of talked about this. Okay, numbers a little bit less. So approaching 4, which is right here, from numbers a little bit less, I use the function where it's a little bit less, that value is equal to 3. Now numbers a little bit more. approaching from the right. That value is going to be 5. These values are not equal, so our limit does not exist. What's the actual function value? Well, that's down here, and that's going to have a function value of 1. Okay, now using a table of values, pull out your graphing calculator and copy down the function and this table, because we're going to be looking at, okay, what's x going to? This one's going to be our limit as x goes to 2 from numbers a little bit less. This is going to be our function as x goes to 2 from numbers a little bit more. We're going to be using our calculators to help fill in this table. So pull out your calculators for a minute. The calculator can really help us find a table of values fairly quickly. So the function that you want to put in, you go to y equals. Now put the whole numerator in parentheses. Close the parentheses where you finished your numerator, divided by what was in the denominator. Close your parentheses. Okay, now what we want to do is we want to use the table. The table is right here where it's second graph. But I want to set up the table since we had such specific numbers that I just want the calculator, I want to tell the calculator which values of x I want. So if you go to table set, which is second window, doesn't really matter where we set our table start, but just for future reference, that's this first value here where the table starts. Delta table, what the table goes up by, goes in increments of 1. But what we want to change is we want to change it, the independent, which is the x values, we want the calculator to ask for those. So notice how the table now is blank. So now go to your table. Notice how the table's blank for your x and for your y values. Now if I put in 1.75, that gives me the x value, with the x value gives me the y value. So now keep putting in the values that you need to help you fill in the chart. And hopefully you wrote the chart down. If not, we'll be going back to it in a minute. Now notice at 2 it gives us an error. Think about the function. What happens when I put in 2 into the denominator? That would give us 0 on the bottom, and we can't have 0. So now I get to my last value that will fit on the screen. So make sure you've written all these values down. Now I have 2 more values I need to find. You can just type over, essentially, and it's going to delete that previous value. So make sure you type over them as you go along. Okay, so now I have all my values. Now I'm going to flip back to the PowerPoint and finish the problem. We used our calculator to help fill in the values, so I'm going to fill these in real quick for us. Remember, for 2, we got an error, which it's our calculator's way of saying this does not exist. Now think of why. If I plug in 2, I'd get a 2 in the denominator. I'd get a 0 in the denominator, I apologize. Now let's look and see. As we approach from numbers a little bit less, what value are we getting really close to? Well, 0.999, that's really close to 1. So it looks like our limit from the left is going to 1. From the right, our number's a little bit more. What am I getting infinitely close to? I'm infinitely getting close also to 1. So what is our limit of our function? The limit of our function is equal to 1. And we're going to talk tomorrow about a way that we can solve this algebraically. Please make sure your lesson video summary is submitted on time.